السلام عليكم. لا تنسوا الإعجاب بالفيديو والاشتراك في القناة تشجيعا لنا لنستمر بنشر المزيد إن شاء الله.
Although this method of using reaction torques is similar to the one that is used to stabilize satellites in space, due to gravity, the algorithms used here are very different. With this setup, the cubely can robustly balance around its corner while rejecting disturbances, rotate while balancing, and balance on its edge. Balancing on a corner is achieved through two subsequent jump-up maneuvers. The first maneuver raises a cubely from one of its faces so that it balances along one of its edges, and the second raises it from its edge to one of its corners. In addition to balancing, the motor torques can be used to achieve a controlled fall, such that the cubely can be commanded to fall in a specific direction. Combining these three abilities, jumping up, balancing, and controlled falling, allows the cubely to walk across a surface.
Our objective is to design self-assembling and self-reconfiguring robot systems. These are modular robots with the ability of changing their geometry. If we do not know ahead of time what the robot will have to do and when it will have to do it, it is better to consider making modular robots.
And so the approach that we chose is to use angular momentum. And essentially what that means is there's a spinning mass that spins inside of the robot. When we want the robot to move, it stops that spinning mass, which takes that motion from the mass and applies it to the robot. The robot doesn't have to be in a certain position in order for the force to be acted upon the robot. And in our robot, we found it kind of as an accident that they're able to jump. We weren't intending to do that, but it ends up that we need enough momentum inside each cube in order to move on a lattice structure, which is what we intended, that we can also, when we apply as much energy as possible,
those are transferred over a wireless link, like your Wi-Fi system in your house, and then the cube responds to that. In the future, we envision putting the algorithms on the modules themselves so that they completely autonomously, in a distributed fashion, decide how